This is the step for the R and N. We need to initialize the hidden state. It means we need to determine the H0. Usually it is determined by the weight. We have the initial weight, and then we will multiply with the value of X. So we can initialize the hidden state and the other parameters, and then compute the hidden state at the time step t. So the t is the time step. If it is 1, then t equals to 1. If it is 2, then t equals to 2, and so on. So we are going to the next step. If we need to compute the yt, then we calculate the output. And then for every hidden state, it will be from one step to the next. We will process until the final hidden state. So what I explained yesterday, we got the initial weight. The initial weight from the previous lecture note, it was 3 multiplied by 2. Okay. But actually, it was my mistake. It should be 2 multiplied by 3. So it should be 2 multiplied by 3. In some cases, if you look at the literatures, they will do some kind of transpose actually. So that's why when I wrote this one, I confused with the transpose. The matrix can be transposed. If the matrix is transposed, of course, the structure will be different. So this is the matrix 2 multiplied by 3. There are 2 rows and there are 3 columns. And what I mentioned before, this is randomly generated. So there are many algorithms to do the randomly generation for this kind of weight. Let's suppose we have this weight. And after we have all the weights, so this is the weight for hidden to hidden, and this is the bias, and this is the initial hidden state. For this initial hidden state, you can determine based on your data, but usually we can start from 0. Then we can calculate. We can calculate if it is the function to get the h and the x, then we do with the formula given from the previous page. In this case, let me just use the tangent. So yesterday, I think we had some problem in this section. I fixed this one. Okay, you can download the new materials. Then if you look at this one, it is the matrix of 2 rows and 3 columns. And this is the vector from the x, which is x1, and we have the word I. We have the word I, log, and LP. If we create a vectors, then x1 is 1, 0, 0. x2, it is 0, 1, 0. And x3, it is 0, 0, 1. The first column indicates the word I, the second column indicates the word log, and the third column indicates the word NLP. Then if I'm going to check what would be the vectors after we calculate with the weight and the x, then we can get 0.5 multiplied by 1 plus 0.3 multiplied by 0 and 0.9, 0.6 multiplied by 0. Everything by 0 means 0. then we get the value 0.5. And for the second value, we use the 0.8 multiplied by 1, 0.2 multiplied by 0, and 0.4 multiplied by 0. Every number multiplied by 0, it will be 0. Then we got this value. Okay. So actually this value is correct, but I was a typo on this matrix. And then, yeah, you can get the other kind of calculation. In this case, you can calculate the width and the H0, and then you can calculate the bias. At the end, we got the Wx, the W. This is the new value, the new H1 after we do this calculation. But in order to get the H1, we need to calculate with the tangent value. So after we apply the tangent, we got this one. This is the new H1. We need to calculate the H2. Okay. We need to calculate the H2, H3. Then we, in the time step 2, we calculate the word love. So the word love, we have the factor 0, 1, 0. And then we do the calculation, the same formula. We use the same weight, but now the factor is different. It is 0, 1, 0. Then we calculate 0.5 multiplied by 0 minus 0.3 multiplied by 1 and minus 0.6 multiplied by 0. So we got the value minus 0.3. For the next value, we have 0.8 multiplied by 1, 0.2 multiply, 0.8 multiplied by 0, 0.2 multiplied by 1, and 0.4 multiplied by 0. Then we got this value. The remaining are the same. And we can get the value of H2 after applying the tangent function. Then we got H2. Next, we will calculate the H3. The same. With the formula, we have H3 and we have the W, which is the width, multiplied by the X3, and the height of the hidden to hidden multiplied by the H2 plus the bias. So this is the width multiplied by the X, and then this is the width multiplied by the H, and we can calculate with the bias. After all, we want to apply the tangent function. Then we got this value. And we got the H1, H2, H3. After we got the H1, H2, H3, then we will do again from the beginning after we update the weight. Okay. So the width, we will update the width of XH and the width of HH. We do the neural network to update the width. And after we got the new width, again, we will do the multiplication with the H0, H1, H2, H3. And then again, we will update the WXH, we will update the WHH, and then again, do the calculation H1, H0, H0, H1, H2, H3, and then, and so on. So when we need to finish this loop, we will finish this loop until we got the minimum loss. So if the loss already minimum, and if the loss already stable, so if the loss, let's say, is already 0.1, 0.01, and then in the next loop it is 0.01, in the next loop it is again 0.01, then we stop because the loss already stable.